Hey, everyone. So thanks so much for coming. We've got a whole lot we want to get into today, so we're going to get started. There's been a huge increase in the prevalence of devices that are able to mix the real world and the virtual world into a seamless mixed reality. And these experiences are able to blend the wonder and power of digital multimedia experiences with the richness and complexity of the real world. And for me, it's really exciting because mixed reality is an opportunity not just to define the future of how we interact with computers, but also the future of how we interact with the world around us and each other as well, which you got to admit is pretty cool. I'm Daniel Plemons. I'm a senior interaction designer here at Microsoft, and I mostly work on the Microsoft HoloLens and the immersive Windows mixed reality headsets.
And I'm Blake. I'm a developer who worked with Daniel on trying to solve these really interesting UX problems that we've encountered on these new types of devices.
So if you saw the day one keynote, then you're familiar with Microsoft Layout. Layout's a space planning application that lets you design your space, collaborate with others, and see designs in a mixed reality environment before you commit to building in the real world. It's a really interesting application, and Blake and myself and a team here at Microsoft have spent a fair bit of time working on it. And we've learned a lot of really interesting things about developing for mixed reality. One of the most interesting has been that a lot of our partners are deploying mixed reality technologies in incredibly large spaces, like warehouses and factory floors. And that's presented some interesting challenges for us from the engineering and user experience side of the world. And we'd like to share a bit of what we've learned with you today.
Like Daniel said, we've built an application that works from all the way to room scale, which is what a lot of developers are used to working in today, all the way to these really large-scale warehouse and factory floors. And as you can imagine, your UX has to be really adaptive to work in both of these environments and in between. And so that's really all the lessons that we're going to share with you today, is what we've learned in trying to make it so that we can build experiences that scale across this entire range of spaces.
So Layout works across both the HoloLens and the immersive Windows mixed reality headsets, but we're going to focus today on what we learned building the HoloLens side of that experience. There's been a lot of particularly interesting things for those see-through mixed reality sides of the equation that we think are pretty interesting.
We've learned a lot of different lessons while building Layout and encountered a lot of different challenges that we've had to solve. And part of that is a bunch of general purpose learning that we'd like to share with you today. The first thing we're going to get into is all around UI and how we've solved interesting UI challenges that have to do with scale and occlusion and size of the different elements that you want in order to make it feel like that UI has physicality in the world. It's all about how do you really create this sense of a mixed reality. The next thing is, as you can imagine, when you're in a really small space versus a really large space, you're going to need entirely different interaction mechanics. So we're going to get into the different interaction modalities that you'll encounter. Then finally, we want you to be able to make it so that the anchoring, the positioning of the real and virtual world feels like it's what users expect, and it feels aligned to create that sense of mixed reality. So we'll get into some developer and design details around that.
So like Blake said, we're going to start off by talking a bit about some things we learned about deploying mixed reality UI alongside the real world. One of the things that really struck me when I first started designing for the HoloLens was how little control I had over the environment around me. When I've been developing traditional room scale applications or like smaller scale consumer applications, I often am able to ask people to clear off an entire play space, or I can get a really clear sensor picture of everything that's going on around me. In some of these larger scale applications, I'm not able to do that. And so I have to design UIs that are going to adapt to the real world at runtime. Now, this is an illustration that kind of shows you a few of the things that we run into a lot of the time. One of them is view angle. We have an untethered device, and so somebody can come at our UI and come at our content from any direction. Another is occlusion, or when one thing gets in front of something else. In these large-scale environments, there's just a lot of content out there, both physical world content and digital content that's being projected into the world, and your UI needs to be able to adapt when things are getting in the way of each other. And then invariably, we have a UI that someone wants to interact with at 2 meters away, and then later they want to interact with it from 20 meters away. And so we have to figure out how do our UIs adapt to those different distances and still stay usable and accessible. For view angle, one of the things that we use a lot is a technique called billboarding. If you've done 3D application development in the past, this is probably something you're familiar with. It's just the idea that a piece of content will rotate to always face the user. In this case, though, when we were trying to deploy these in mixed reality, we have to make a couple of tweaks to more traditional billboarding. And one of the things in this illustration that's a bit subtle but is important is that thresholding. The fact that we are only updating the rotation when we have to maintain usability. And that's buying us two things. The first is that thresholding makes the UI feel more physical. If we're constantly rotating, it immediately makes the UI feel digital and ephemeral rather than weighty and physical. And then the other thing we're getting from this is we're helping reduce cognitive friction and discomfort. When you have really large UIs especially, if you're constantly rotating them, it can actually confuse your brain's perception of the 3D space. It can actually lead to a little bit of discomfort. So for us, having this thresholding is really important. We'd use the same effect when we're adjusting for view distance. One of the things we do a lot in our UI is we will rescale it depending on how far away you are from it, so it always has a comfortable size in your field of view. Large enough that it's interactable, but small enough that it comfortably fits within the field. But again, we want to make sure that we're thresholding that and we're only updating when we have to maintain that sense of physicality, and then also to make sure that we're not confusing your brain's perception of 3D space. Scale in particular, as you're moving through a space, is something that your brain uses to understand where things are. And so we want to be very cognizant of that as we're making our UIs adapt.
The next challenge here that we encountered while building layout had to do with occlusion. We found that when there were physical and virtual objects that were occluding the menu elements you wanted to interact with, that was a problem for the users. And so our immediate thought when we encountered this was that we should just make it so that we draw the menu elements through everything. But as you can see here with this illustration, you lose a real sense of depth about where things are in the world when you change that draw distance. You're getting a lot of inferences about where these UI elements are, and like we've been saying, that loses that sense of physicality. So we realized this wasn't a good solution to the problem. The other issue that we encountered with this is that there's this menu in the back right next to that pink cube. And when the draw order is all correct, when everything's in the right place, it looks like those elements are associated, but when you change them, they no longer look associated anymore. So we thought of a few different ways in which we could always be smart about our menu positioning so that we wouldn't have occlusion issues, but there's a lot of variables you have to deal with, especially in really large spaces. So what we ultimately went with is letting the user be in control of the menu. As you can see, the user can just pick up the menu and place it where they want it to be so that they can define the current workspace that they're working in. Now, as Daniel's been talking through, we make the menu adaptive to the environment. It scales nicely so you can interact with it from distance. It turns so that you can interact with it from whatever angle you're at. And you can also make it so that it's on any type of different surface or wall. That makes it so that you can place it on a wall near you, make it so that that's the current space you're working in, and then go move somewhere else.
So there's three big takeaways we want you to have when you're thinking about your own UIs and how you're going to create interfaces and content that exist alongside the real world. And first off is that you don't control the environment. And you want to adapt to the environment and the different things that are happening in the space at runtime so that things stay accessible and usable. And while you're doing that, you also want to think about how you make sure your UI has a sense of physicality. In our case, we were using that thresholding along with some other tricks to make sure that things feel weighty and real. And then there's going to be a lot of application-specific decisions that you make and a lot of application-specific things that you run into. There certainly were on layout. But with almost any mixed reality UI that's going to exist in the world, you're going to have to think about how you account for angle, occlusion, and distance. And you're going to want to think about that early on so you have a nice, consistent experience throughout your application. Next up, we're going to talk a bit about varied interaction distances and how we kind of approached that when we were working on layout. Like Blake said earlier, a lot of our partners are working in spaces that have a really wide variety of scales, from room scale all the way up to factories and warehouses. And so we wanted to make sure that our user interfaces could adapt to all of those in a reasonable way. When we first started looking at layout, we knew that one of the most important things to nail was going to be how do we place objects in the space, and then how do we manipulate them once they're there. And so when we were starting our development, we did a bit of a usability study across all of the existing UI and UX patterns that we had for doing that, trying to understand how they were going to adapt to the space that we were in. We started off by looking at one that we call ray-based placement. With ray-based placement, what you do is you take the orientation of the device, you cast a ray out into the world, and wherever that ray intersects with the environment is where you're placing the object that you're manipulating. This is something we've seen in HoloLens for a little while now. Ray-based placement is fantastic when I want to make large sweeping motions. I can stand here and I can address a really significant part of the room without having to move my body all that much. But it does start to break down when I want to move things with a lot of precision, move things in full 3D space. And so, and also when I want to get things up really close to me, because then I have to move my neck a lot more, and you can start to run into some ergonomic issues. So it worked really well in some of our scenarios, but not so well in some others. Another one that we looked at was using gesture. With gesture, one of the things we could do is you can look at the object that you want to interact with, reach out with your hand, air tap and drag, and then have the object follow the motion of your hand. This is really intuitive. People kind of expect this sort of interaction a lot of the time and pick up on it very quickly. And it works very well close up or when I want to move with a lot of precision. It also works really well in full 3D, but it breaks down in some of the places where that ray-based placement works quite well. One of them is those large sweeping motions. The HoloLens has what we call the gesture field of view, which is the large cone in front of the device where the sensors can easily track your hands in 3D space. If I'm in the middle of a drag and my hand falls outside that gesture field of view, it'll force me to drop the object, and that can be a bit frustrating. So those large sweeping motions sometimes don't work so well with your hand. Also, there's an element of fatigue when you're interacting with your hands. If I've got my hands up above the level of my heart for an extended period of time, it's going to cause a certain amount of fatigue, and so we have to be aware of that when we're figuring out where we use these different interaction modalities. And so we were kind of scratching our heads because we were looking at all of these different modalities that we had, and they didn't cover the full gambit of interactions that we needed. But as we were watching our user studies and kind of trying to understand how people were working, we started to notice this pattern, and it's what we call the roughen and refine loop. It's going to be really familiar to anyone who's ever done visual art. You start off with a sketch before you go in and do your details. It's exactly what we saw our user test participants doing. They would stand in one part of the room, quickly shotgun a bunch of assets out into the world, kind of rough things in, then they would walk around the space. They'd look around, they'd understand the sight lines, they'd understand how everything was working, and they'd refine things. And we realized that this mapped really well to using that ray-based placement for the initial placement from our menu into the world, and then for everything after that, using that hand-based interaction. But we were really worried that this was introducing this huge inconsistency in our interaction, and that was going to cause usability problems. So we built a prototype, and we did a user study. And what we found was pretty cool. A lot of people didn't even notice we were swapping input modalities on them. They just naturally went from one to the other. And the people who did notice were still able to naturally adapt and utilize the tool very effectively. And the reason I think this worked is that what we did was we found an inflection point in our users' goals. When they moved from roughing things in to refining, the way they wanted to interact, the distances they were interacting with changed, and we were able to optimize without causing a major usability problem, which was pretty cool. So there's a few takeaways that I'd really like you to get from this. And the first is that not all interactions are going to work at all distances. And more generally, you want to really understand where certain UI and UX patterns are strong and where they're weak so you know where to apply them appropriately. And I'm really a broken record about this for anyone who knows me, but research and observation, research and observation, research and observation. As much as you can be prototyping, as much as you can be user testing, it's really important. And as much as you can do that in a real-world context, it's even better. If we hadn't actually been doing our usability studies with a scenario that was very similar to the one we were working with, we never would have noticed that roughen and refine loop, and we wouldn't have known that we could optimize for it in our UI. And then lastly, different interaction distances are often going to mean different goals. And for us, finding that inflection point in our end users' goals was really important to making sure that we had an effective experience. So as much as you can find those inflection points in your own applications, that's a place that you can dig in and start to see if you can optimize your interactions.
The final challenge that I'm going to talk about today has to do with aligning the virtual and the physical space through what are called anchors, and trying to make it feel like there's this real sense of mixed reality and also respecting kind of user intention. So in order to explain this, I have to really quickly go over inside-out tracking. The Microsoft HoloLens and the immersive Windows mixed reality devices all have cameras and sensors on board that are able to track the relative position in space. They do this through identifying uniquely identifiable feature points in the area, and using those feature points, they're able to track their own position in space. Likewise, the HoloLens is able to track assets positions, 3D holograms positions in space as well. The way that this works is that developers can specify anchor points, which are 3D positions in space that things should be tracked around. So to take this example of a chair here, let's say that we place this chair and we decide that there's an anchor point that we're going to place near this chair that's near this parking lot sign right here. And so as you're moving around the space, this chair is always going to be tracked relative to some anchor point that's been specified. So there's something you have to be aware of, though, around anchor points and setting anchor points, and this is known as the lever arm effect. Basically, the HoloLens is always updating. It's trying to get a better understanding of the features in space and where they are, and so it's constantly updating its own knowledge. And what happens, though, is that if you have objects that are far away from an anchor point, small rotational offsets can cause large positional offsets. So you can see that here. We have a chair that's really close to this anchor point, and then we have a chair that's a bit further away. And the chair that's a bit further away has a much more magnified displacement when you have that small rotational change. Now, in order to get around that, we recommend that you place objects within 3 meters of any anchor point.
So anchoring in general feels like a very technical topic, but as a designer, it's actually something I have to think about a fair bit. When we're working in smaller scale applications, we can often just follow that 3-meter rule and everything works out really well. And that's what you want to do most of the time. But one thing that we ran into in these really large environments or with really large content is that we can't always follow that 3-meter rule to a T, and we had to think a little bit about the strategies we were using to make sure that we accounted for the lever arm effect and the other behaviors of anchoring appropriately. At the end of the day, there's kind of 2 extremes you can optimize for. The first is hologram to hologram consistency. And this is the idea that you're going to put a whole bunch of holograms all on the same anchor. Now, if those holograms are more than 3 meters from the anchor, you're going to see lever arm effect. But when that anchor shifts a little bit, all of those holograms are going to move together. They're going to maintain their spatial relationship. And sometimes that's very, very important. On the other end of the spectrum is hologram to physical space consistency. And that's going to be where we have our holograms all on separate anchors or grouped around anchors that they can be very close to. So you're going to see reduced lever arm effect, but if an anchor shifts, the holograms that are attached to it might shift relative to other holograms in the space. It can be a little unclear where to apply each of these, so Blake's going to go over some really concrete examples.
So let's say that we're going to lay out a banquet hall. And so the first thing we're going to do when we're laying out this banquet hall is put this really large banquet table in the space. So this is an object that we place, and we place an anchor point along with it, because what we really care about here is this banquet table and its position relative to some physical point in space. In this case, this exact spot on the floor. The next thing we're going to want to do when we're designing this space is put some chairs around this table. And the way that we can do this is via both of the ways that Daniel just went over. So the first way is making it so that each chair has its own anchor point in space, just like the table, making it so that the chair is aligned with a specific point on the floor. Now, the issue with this is that as the table might shift, as the hologram updates, or the HoloLens updates, the chairs are not going to shift along with it. And so it's going to cause this kind of weird effect like you see here, where they don't feel like they're one cohesive object. And this doesn't really seem like the data that the user is trying to express here either. So the solution that works better here is that hologram to hologram consistency. We want the chairs to share the same anchor as the table. Now, this will cause the lever arm effect because it's going to be larger than 3 meters wide, but it will represent the correct consistency that the user desires, and it represents the data that they really care about. Now to look at an example of where you do care about the objects having their individual anchors, we're going to place lamps in either corner of this room. Now, we could make it so that these lamps are all around the exact same anchor point, but then as the device updates, you might see those lamps go through the walls a bit, and that's not going to give you that sense of physicality. It won't create that sense of mixed reality, and most importantly, it's not what the user expects. And so we recommend for like that scenario, making it so that each lamp has its own anchor in each corner of the room so that it feels like and looks like they actually belong there. The final scenario is, let's say we're placing a bunch of objects. We want them to be in some actual physical location, just like those lamps, but they're all within 3 meters of the same anchor point. If you give them all their own individual anchors, you'll see something like with the chair earlier, where as stuff updates, they might not update together. So we recommend that if objects are within 3 meters of the same anchor point, and you care about their own physical location, you batch them around the same anchor. That way it will look like they belong as a single cohesive unit. So we went over the lever arm effect, how to identify it, and that 3-meter rule for if you want to mitigate it. And then 2 different ways of dealing with it, either with anchoring strategies. Either hologram to hologram consistency, where you care more about the virtual objects relative to each other, or those holograms to physical space. If you want more information on anchoring, we have some documentation that you can find out online.
So we've talked about 3 big themes here that I think are really relevant to anyone who's going in and starting to create mixed reality applications. First off, we talked about UI and the environment and how you don't control the environment and UI needs to adapt to it at runtime, but you also want to make sure that you're maintaining a sense of physicality and really that consistent sense of mixed reality. We also talked about how with varied interaction distances and varied contexts, you might need to optimize for different interaction mechanics, and that it's best to use prototyping and good observation and good research to figure out how to do that best. Then lastly, Blake talked about different anchoring strategies and how we can align our virtual and real worlds in the best way possible to give ourselves the best user experience possible.
And like we mentioned earlier, these are really general tips for building all types of applications that we learned while building layout. And we keep refining our designs over time. It's an iterative process, and we're going to continue sharing what we've learned with all of you.
If you're currently building 2D applications and you're interested in how you can start to bring those experiences into mixed reality and into 3D, we really recommend Mike Harnish's talk in this theater tomorrow at 1:30. He's going to talk a lot about how the Fluent design framework can help you bring 2D experiences into 3D and into mixed reality. So if you're interested in that, should be a great talk.
We're a bit out of time, so we'll have to take your questions on the side. But I'm Blake.
And I'm Daniel.
And we're hiring for our team in Redmond, so we'd love to work with you. And we'd love to get feedback on how we were today, so please fill out any speaker surveys. Thank you.
Yeah, thanks much.